Okay, good morning everyone. So welcome to
Evening, sir.
EMWTL class. So this is the first class. A few things I have to tell to you. All of you uh, save your with your roll number 19ME and some 434 something like that. Okay. So save with your roll number. That is the first point, so that it will be easy for us to give attendance. Second thing is attend classes regularly. And third thing is I will be taking attendance randomly. So when I'm taking attendance, you people has to switch on your video so that I will know you are present. So follow these three things. Even while during the class, better to take notes, running notes. Anyhow, I will be sharing the PPT later. Better you take the running notes. If you have notes, you can see it and follow it. So this class, I am going to review Unit 1 once again. So Unit 1, it is about uh, transmission lines 1. Transmission lines 1. So what is the importance of this particular subject? And one more thing, remember students, some people are just joining and leaving. Everybody, please note down. In Google Meet, there is a separate attendance. It is recorded online. It will show us what time you have joined in the meeting and what time you have left the meeting, how much time you are there in the class. All complete information we will be getting from Google Meet. Some people are just joining and leaving the meeting. So don't do like that. Listen carefully so that you people can understand in a better way. So what are the applications of electromagnetic waves? You can see in this slide. Can you see the second slide, electromagnetic waves and transmission lines? Which slide you are seeing? The second slide, right? Yeah, somebody can respond.
Yes, sir.
So in this slide, what you are seeing is different applications of electromagnetic waves. So the first one shows what is electromagnetic radiation. See here, this is the wavelength. It is also defined in terms of frequency. As we are moving towards right side, what we are observing is the frequency is increasing. And as we are moving towards left side, the frequency is decreasing. So we have low frequencies, medium frequencies, high frequencies, very high, super high, ultra high frequencies, then infrared, then visible light, then ultraviolet, X-rays and gamma rays. So you can see in this diagram, uh, radio waves. So radio waves is a combination of high frequency and very high frequency in microwaves. After radio waves, we have infrared. There are separate applications for each frequency range. Then we have visible light, then ultraviolet, UV radiation, then X-rays, then gamma rays. So just we are going to see what are the applications of these radio waves. So high frequency and very high frequency signals, they are in megahertz or 10 power 6, from 10 power 6 to 10 power 8. They are used for broadcasting, radio and TV. Then microwave frequency range, that is 10 power 8. They are used for cooking, that is microwave oven. They are used in radar. They are used for mobile communication and other applications. Then we have infrared, infrared radiation. In infrared radiation, we can see that it transmits heat from sun. Yeah, it is used in radiators and other applications we can see in infrared. Even TV remote also operates at infrared region. Then we have visible light. Visible light means white light. So we are using optical cables for white light, for white light. So here, after visible light, we can see ultraviolet radiation. In ultraviolet radiation, they are used for different applications. They are used in fluorescent tubes. And these UV rays, they are absorbed by skin. Then we have X-rays. So X-rays, they are used to detect objects and bones inside our body. Then gamma rays. Gamma rays are used for treating cancerous cells. So these are the different applications we see in from low frequency to very high frequency. Next, in our syllabus, we are going to see different types of transmission lines. So our first unit type transmission lines 1, we are going to see different types of transmission lines. So all these transmission lines, they are used for different applications. And what are the types of transmission lines? This is first topic. Second topic is primary and secondary constants. Then equations of transmission lines, parameters of transmission lines, phase and group velocities, infinite lines, lossless and distortionless line, and types of loading. These are all the different topics in Unit 1. First topic is what is a transmission line? So transmission lines are used to carry energy, electromagnetic energy from one place to another place. That is from source to the destination. They guide the energy in a proper direction. So generally they consisting of two conductors and they are used to transmit electromagnetic waves over long distance between transmitter and receiver. So just now I have shown you different applications, right? Slide Marthandamma. Can you see this slide? Types of transmission lines?
No, sir.
No, sir.
Slide is not changing.
No, sir.
No, sir.
No, I came to fourth slide. I think still in second slide only, right?
Yes, sir.
Yes, sir.
Maybe it is taking some time. So now I have come to fifth slide. Types of transmission lines.
It is in only second slide, sir.
That's what I'm also seeing.
Yes, sir. Now it came.
Now it changed, no? But it is not showing full screen. It's
Yes,
showing
sir.
only. Okay. So in types of transmission lines, the first one is two wire or parallel wire. Two wire or parallel wire. Second type of transmission line is coaxial cable. Third one is twisted wires. Fourth one is optical fiber cable. Fifth one is waveguides. Sixth one is strip line. And seventh one is microstrip line. These are all different types of transmission lines. So based upon the application, we are using different transmission lines. Now we are going to see what are these transmission lines in detail. So if he is asking for 3 marks, what are types of transmission lines? You can just write these 7 types of transmission lines. If he is asking for 7 marks, explain types of transmission line, you have to explain in detail. You have to explain in detail. So first one is parallel line. First one is parallel line. So what you are seeing in a parallel line is, uh, so there are two wires, that is two conductors. They are separated by some insulating material, and they are placed at equal distance to each other. So they are called as parallel wires. Generally, we see parallel wires around us. You can see the current wires. They are parallel to each other. And current wires, there is nothing in between them. So air acts as a dielectric material. And in the top, I have drawn the field distribution, electric field distribution. It is going the positive half cycle upwards, and in the negative half cycle, it is going downwards. So in a parallel wire, the fields are not confined within the conductors. So it is a disadvantage for parallel wires. Second one is coaxial cable. You can see the coaxial cable construction. What is there in a coaxial cable? There is an inner conductor and there is an outer conductor. There is an inner conductor and there is a outer conductor. And this is outside, it is the insulation. So inner conductor is connected to the signal and outer conductor is connected to the ground. Between inner conductor and outer conductor, there is a dielectric material. There is a dielectric material. See, here also the construction is similar to parallel wires. Two conductors separated by a dielectric material. Generally, coaxial cables, they are used at frequencies up to gigahertz. In laboratory, you are using coaxial cable for connecting CRO probe. So there, I think you are using 20 megahertz frequency, right? So coaxial cables are used to transmit signals up to 1 gigahertz. So this is the construction of coaxial cable. Generally, they are used for transmissions and mobile communication. All high frequency, very high frequency applications, we are using coaxial cables. And here, one important thing you have to observe is, see here, this is the electric field distribution, red color. In electric field distribution, I have drawn the cross-sectional view. There is an inner conductor. So from inner conductor, the field is coming outside towards outer conductor. See the arrow marks. So the arrow marks indicate the direction of the electric field, the direction of electric field. The electric field is coming out of the inner conductor towards outer conductor. So here what we can observe is the fields are confined. The fields are confined within the transmission line. That is the advantage of coaxial cable. Next, we are going to see another type of transmission line, that is twisted pair. See, these cables were used for telephone communications in previous days. Now, telephone lines, they are using optical fiber cables. So, inside this orange color thing is there, tube. In this, there are a lot of small copper wires. They are separated by insulating material. So there are multiple wires which can be used to transmit different signals. Maybe we are using different multiplexing techniques like frequency division multiplexing, phase division, time division multiplexing, and phase division multiplexing. Okay, so these twisted pairs, they are used in transmitting signals from one place to another place. Even the wires we use inside our home for connecting the fan, tube lights, all these devices, they are using twisted pairs. So this is an example for twisted pairs. They are having two conductors. Next one is strip line. So what is this strip line? This is a uh, another type of transmission line. So far we have learned about conventional transmission lines, which we see in day-to-day life. But now we are seeing another type of transmission lines where we can see that on a printed circuit board, we can use this transmission line, which is called as strip line. So the transmission line is similar to a what do we say, on the PCB, there are connections between the components. So similar to that, the transmission line is construction is present. These transmission lines are called as planar transmission lines. These transmission lines, they are called as planar transmission lines. Planar means they are on a single plane. So they can be used at frequencies from 100 megahertz to 100 gigahertz. They are used from frequencies 100 megahertz to 100 gigahertz. So a strip line consisting of a thin conducting strip of width W, which is greater than its thickness. So here we are seeing that this is the strip line, and this is the center conductor, and these are outer conductors. So what do we understand is two conductors separated by some dielectric material. Two conductors separated by dielectric material. And here the fields are shown by red color arrow marks. So the electric field is between center conductor and ground plane, and here the field is between center conductor and ground plane. So from this, we have next type of transmission line, that is called as microstrip line. This is called as microstrip line. This microstrip line, one type of transmission line which we use on a PCB. So most of these transmission lines are used in mobile phone, even in laptops, even in your latest gadgets. All latest gadgets, we are using these type of transmission lines. They are called as strip lines or microstrip lines. The advantage is they are also having similar construction that of a PCB. Bottom ground plane will be there, which is nothing but a copper. See here, you can see this is a copper, and the top is also a copper, and in between we have a dielectric substrate material. So that is the construction of a microstrip line. And from this microstrip line, we got microstrip antenna. So most of the wireless devices, all wireless devices are using microstrip antenna. It is coming from this microstrip line. So what is the construction of this microstrip line? See here, top and bottom, we have two conductors, and in between a dielectric material is there. So here the width of this conductor and the thickness of this dielectric material, they can be varied. And if you want to get different, if you want to change their output parameters by making changes on construction, and we can make the changes in the output parameters. The advantage of this microstrip line is by using software, we can design, simulate, and see the output results. And if you are satisfied with the output results, then only you can go for fabrication. Whereas conventional transmission lines, you have to, after manufacturing, then you have to test its performance. You have to observe carefully observe the difference between these two. Conventional transmission lines, initially they are fabricated or made, and after they are made, they are tested for their performance. But these microstrip line and strip line, they are first developed, designed by using a software, simulated, and we will be seeing the output results. Then only they are going for fabrication. So that is the advantage of microstrip line. And here, these microstrip lines, they are used in integrated circuits like microwave monolithic integrated circuits, which are called as MMICs. So in MMICs, we are using these microstrip lines. Next type of transmission line is rectangular waveguide. So till now we have seen about three types of waveguide, four types of transmission lines. So what are they? Parallel wires. Then we have seen coaxial cable. Then we have seen microstrip line, strip line, and then we have seen microstrip line. All these are operating up to gigahertz frequency range. So now the question is, if I want to go for higher frequencies, what I have to do? Can I use these transmission lines? The answer is no. Yes, if you use these transmission lines, what happens is there are losses in the transmission line. There are losses in the transmission line. So what type of losses? There are radiation losses, there are attenuation losses. Because of these losses, we cannot use these transmission lines. So we are going for another type of transmission line, which is called as waveguide. See, in this diagram, you are seeing a waveguide. So waveguide is a hollow metallic structure. See, this is a waveguide. It is a rectangular waveguide, and inside it is hollow. That means air acts as dielectric material. And these waveguides are having dimensions. This broad side is A, small a, and this narrow side is small b. These waveguides, they allow high frequencies. They will not allow low frequencies. That's why they are called as high pass filters. We know about high pass filters, right? What is the purpose of a high pass filter? It allows high frequencies, it attenuates low frequencies. Similarly, the waveguide allows only high frequencies and attenuates low frequencies. So you can see the waveguides, they are made up of conductors. And next you can see different types of waveguides: rectangular, circular, elliptical, rigid waveguide, and double rigid waveguide. Just now I have shown you rectangular waveguide. That means it is having rectangular cross section. Circular waveguide, which is having circular cross section. You know, in our home we have tube light. So tube light is similar to a circular waveguide. And rectangular waveguide, it is having a rectangular cross section. Ellipse. If the shape is like an ellipse, we call it as elliptical waveguide. And these two are rigid and double rigid waveguides. So what is the use of these rigid and double rigid waveguides? So in a waveguide, as I told you, it operates at high frequencies. At high frequencies, what are the two components that are important? L and C. L means inductance and C is conductance. So if you want to vary the value of C, you have to change the top and bottom values. So here the top and bottom plates, the distance has been changed. That means we are changing the value of C. Here also top and bottom plates, the distance has been changed. Yeah, the question is why we are doing. For different applications, we are going to change the values of L and C. So these are all different types of waveguides. Last type of transmission line is optical fiber cable. So optical fiber cable, nowadays we are seeing in day-to-day life that orange color plastic tube will be there also near to the road. What is that? It is nothing but a optical cable. So inside, what is the material that is present? It can be a glass or it can be plastic. So glass easily breaks. That's why we are using plastic. Now, what are the advantages of this optical fiber cable? More bandwidth is available in optical cable compared to coaxial cable or waveguide or parallel wire. And nowadays we are getting high speed internet. Because of this optical cable, it is possible. Another advantage is in optical cable, what is the signal that is traveling? Light. Light is the signal that travels in a optical cable. Compared to conventional transmission lines, we need amplifiers at different intervals, regular intervals, to boost or amplify the signal. But optical fiber, they doesn't require amplifiers like coaxial cable because the signal attenuation is very less in optical fiber cable. And also the maintenance is also less. So these are all the advantages which are provided by optical fiber cable. And also one more important, last but not the least, high speed data can be transmitted through optical fiber cable. Now the government is planning to give internet connectivity to all the villages. So how it is possible? It is possible only through optical fiber network. Okay, so far we have seen about different types of transmission lines. First one is parallel wire, second one is coaxial cable, third one is waveguide, fourth one is strip line, micro strip line, then we have optical fiber. So if he is asking for 7 marks, you have to draw this diagram very neatly and at least 2 or 3 points if you write about each transmission line, then it is more than enough. It is more than enough. You'll be getting minimum 6 to 7 marks. So this is one important question in first unit, and second important question is, what is the equivalent circuit diagram of a transmission line? So here you can see transmission line is having 4 primary constants. They are R, L, G and C. R is resistance, L is inductance, G is conductance and C is capacitance. So if you represent on a equivalent circuit diagram, so R, L, G and C. Here R and L are in series. So from this we can define series impedance Z equal to R plus J omega L. And here if you see the conductance and capacitance, they are in parallel. So that's why they are called as shunt conductance and shunt capacitance. So from this we can define shunt admittance, that is Y. Y equal to G plus J omega C. And these R, L, G, C, they are called as primary constants. And there are 2 secondary constants which are called as gamma and Z naught. Gamma is called as propagation constant and Z naught is called as characteristic impedance. Now, if you look at this R, we are defining this R. as loop resistance per unit length of line. Because all these are defined for a transmission line, we are defining per unit length. Similarly, L is loop inductance per unit length of line. C is shunt capacitance per unit length, and G is shunt inductance, shunt conductance per unit length. And here Z equal to R plus J omega L, which is called as series impedance, and Y equal to G plus J omega C, it is called as shunt admittance. The units are very important. One is ohms per meter and second one is mho per meter. The secondary parameters, they are defined by propagation constant gamma, and second one is characteristic impedance, that is Z naught. So the propagation constant gamma is defined by alpha plus j beta. See, I have written these terms in the class also. So gamma is equal to alpha plus j beta, where alpha is attenuation constant and beta is phase shift constant. And gamma is given by square root of r plus j omega L into g plus j omega C. Similarly, the characteristic impedance is given by square root of r plus j omega L by g plus j omega C. Remember these two formulas, they are useful for solving problems. So in a problem, R, L, G and C will be given. He will be asking to find what is the propagation constant and what is the characteristic impedance. You have to substitute in this formula and you have to find out. Now, what is the propagation constant? So, what is a propagation constant? It is defined by gamma. You can see this expression E equal to E naught into e power minus gamma x. So, this signal can be divided into two parts. One is amplitude and second one is phase. Amplitude means maximum value, maximum amplitude E naught, and e power minus gamma x, that indicates the phase. So here minus gamma means the wave is propagating in the positive x direction. If it is plus gamma, the wave is propagating in negative x direction. So how do we know it is propagating? Because there is gamma value here. Are you following, students? Students, are you following?
Yes, sir.
Yes, sir.
Okay, very good. So gamma is given by alpha plus j beta, and z naught is equal to square root of r plus j omega L by g plus j omega C. Next important topic is equations of transmission lines. So in a transmission line, this is also a very important topic. Many times he is asking for 7 marks. Derive the equations of transmission lines. So here we are going to take a parallel wire. See, this is a parallel wire. Two conductors are there. The length of this wire is small l. And here this is called as sending end, this is called as receiving end. And at sending end, the voltage is V, current is I. At the receiving end, the voltage is VR and current is IR. On the transmission line, I am taking 2 points. One is P and second one is Q. So the distance between P and Q is dx. Actually, the value of x is 0 here and here x equal to L. So at this point Q, in a length of dx, what is the voltage? dV. And what is the current? di. When we are considering the voltage at the receiving end, the voltage is initially V plus dV. Similarly, the current is initially I plus the current in dx is di, I plus di. Now I am going to take the difference of voltages between P and Q. So the voltage at P is V minus the voltage at Q is V plus dV is equal to, we know that V equal to I into R, same formula I am using here, I into what is R? R plus j omega L into dx. Because we are defining this resistance per unit length, we have to multiply with dx. So V minus dV is equal to R plus j omega L into dx into I. So V minus V will get cancelled. So dx, if I bring this side, minus dV by dx is equal to R plus j omega L into I. So that is what I am writing here. Minus dV by dx equal to R plus j omega L into I. R plus j omega L into I. Yes, the same equation. Similarly, the difference of currents, I minus I plus dl equal to I equal to V by R. So 1 by R is nothing but conductance. So what is 1 by R is admittance. Sorry, 1 by R is conductance. So G plus j omega C into dx into V. So I minus di equal to G plus j omega C into dx into V. So I minus I will get cancelled. Minus di by dx equal to G plus j omega C into V. So these are two equations, equation 1 and this is equation 2. Now taking differentiation for equation 1, minus d square V by dx square equal to R plus j omega L into di by dx. We know what is di by dx. Substituting this value here, we get d square V by dx square equal to R plus j omega L into G plus j omega C into V. Here, minus and minus will get cancelled. So we are getting d square V by dx square equal to gamma square into V. Similarly, we get d square V by d square I by dx square equal to gamma square into I. Here we are defining the new parameters, that is gamma. So gamma square equal to R plus j omega L into G plus j omega C. So what is gamma? Gamma equal to square root of R plus j omega L into G plus j omega C. So gamma is called as propagation constant. Now these two equations are called as equations of voltage and current, and the solutions for 5 and 6, equation 5 and equation 6 is given by V equal to A e power gamma x plus B e power minus gamma x and I equal to C e power gamma x plus D e power minus gamma x. So these equations 7 and 8 are called as solutions for this equation. Solutions for this equation. Now, if you look at these 7 and 8 equations, what we are observing here is there is e power gamma x and e power minus gamma x. That means there is a forward wave and there is also a reflected wave. There is a forward wave and also reflected wave. Forward wave is given by e power minus gamma x and reflected wave is given by e power plus gamma x. Similarly, I also can be represented as C e power gamma x plus D e power minus gamma x. So these two are the two solutions for the above equations, that is 5 and 6. Now, we are going to find the value of Z0. We are going to find the value of Z0. So now, take the first equation, dV by dx equal to gamma into a e power gamma x minus b e power minus gamma x. You can ask me from where we got this equation. So here, v equal to a e power gamma x plus b e power minus gamma x. If we are differentiating this value dV by dx, we are getting this equation. dV by dx equal to gamma a e power gamma x minus e power minus b into e power minus gamma x. Similarly, di by dx equal to gamma into c e power gamma x minus d e power minus gamma x. But in equation 1, we know that dV by dx equal to minus r plus j omega L into I. So, this value, if I bring this side, so here you can write gamma equal to r plus j omega L into g plus j omega c. So, substituting this value, I equal to square root of r plus j omega L into g plus j omega c by r plus j omega L into a e power gamma x minus b e power minus gamma x. So, this r plus j omega L will cancel in r plus j omega L root times. So, we are getting 1 by z0 here. Similarly, for v, z0, because this is square root of r plus j omega L by g plus j omega c. So, this value becomes z0. So, these two equations we are going to get if I am substituting the value of z0. Here, I equal to minus 1 by z0 into a e power gamma x minus b e power minus gamma x. Similarly, v equal to minus z0 into c e power gamma x minus d e power minus gamma x. Now, substituting the boundary conditions at the source of the transmission line, x equal to 0, v equal to vs, and I equal to is. That means at the sending end, so substituting we get vs equal to minus z0 into 3 e power 0 and d e power 0. Similarly, is equal to minus 1 by z0 into a minus b. Substituting e power gamma x as cos h gamma x plus sin h gamma x and e power minus gamma x as cos h gamma x minus sin h gamma x, we get v as vs cos h gamma x minus is z0 sin h gamma x. Similarly, I equal to is cos h gamma x minus vs by z0 sin h gamma x. Yeah, these are the equations of transmission line in the form of hyperbolic functions. Maybe in your notes, this approach may be different. No need to worry, but the equations are same. Okay, so the main equations are d square v by dx square equal to gamma square v, d square I by dx square equal to gamma square I. This is important. Then the solution, v equal to a e power gamma x plus b e power minus gamma x, I equal to c e power gamma x plus d e power minus gamma x. This is important. And last, v equal to vs cos h gamma x minus is z0 sin h gamma x, and I equal to is cos h gamma x minus vs by z0 sin h gamma x. So these equations are important when you are doing the derivation. So I think you have followed all these three topics that has been covered today. First one is types of transmission lines. Second one is what are primary constants and what are secondary constants for a transmission line. And then I have also explained about what are transmission line equations. So students, now I will stop here and I want to take attendance. So when I'm calling the number, try to switch on your video. 407, 407, 410, 413.
407 present, sir.
Yeah, switch on your video.
Okay.
Okay. When I call that number, that person has to switch on, not all, because it will
407.
take, yeah, 413, okay, fine. 414,
410 present, sir.
okay, okay, right. Bhargav, switch off chese. Okay, right. 416, 420, right,
Present, sir.
right. 421, 424, 433, right, right,
Present, sir.
right. 441, right. 444, 445, 448, right, right. 448,
Present, sir.
okay. 450, 454, 461, right. 461, 466, 468.
Present, sir.
Okay,
454
okay.
present, sir.
468 present, sir.
8%. 469, 469. 407, mute చేయమ్మా. 472,
469 present, sir.
473, 475, 476.
476 present, sir.
You are there?
Yes, sir.
478, 479,
478 present, sir.
479 present,
480,
sir.
482, 484,
480 present, sir.
486,
484
486 present, sir.
487, 489,
485 present, sir.
89.
490,
89.
491.
487 present, sir.
Nobody is switching on the video. 490. Switch on video. Okay. 491. 491. 492. 495.
Yes, sir.
499.
Present, sir.
On the video. 99. A3.
Present, sir.
A4. A5.
Present, sir. Present, sir.
You are there?
Yes, sir.
A6.
Present, sir.
A7.
Present, sir.
Okay, okay, right. A7. C0. C2. C2. Sleeping, I think. D7. C2 absent. D7. Okay. D7 present.
Present,
No voice. D8. D8. E3.
Present, sir.
Sir, D8 present, sir.
Okay. E3,
Present, sir.
E4, E4, F2.
Present, sir.
Present, sir. E4.
Okay. F9,
Present, sir.
F9,
Present, sir.
G3,
Present, sir.
G7, G7,
Sir, G5 present, sir.
G5 present.
Yes, sir.
Okay. G7, G7 somewhere. G8, G8, H2
Present, sir.
on your video. H8. Okay.
Present, sir. H2
Right.
present.
H8, H8, H9.
H8 present, sir.
Okay. For I10,
I not.
I0. Next, I1.
Present, sir.
Switch on your video. Okay. Ramya Kumar.
Present, sir.
What is the number?
B4, sir.
Huh?
4B4, sir.
4B4.
Sir, 441 present, sir.
Then that's it.
Sir, 454 present, sir.
454. Huh?
461 also present, sir.
Yeah, given attendance 54 and 61.
Okay, sir.
Sir, 410 also present, sir.
Okay, sir.
4,
49, sir. 26,
what?
sir.
426.
449, sir.
475, sir.
475 already given. How many times I have to give?
449, sir.
43 also given.
Sir,
14,
410, sir.
410 already present, ma.
Sir,
449, sir.
469,
449.
sir.
469 already given present.
449, sir.
49.
Yes, sir.
482, sir.
449, who is that?
Ravindra, sir.
On your video?
Yes, sir.
So what topics I covered today?
Today, sir, discussion lesson transmission line, sir.
Huh?
Discussion lesson transmission line, sir.
Distortionless transmission line.
Yes, sir. Characteristic improvement.
That's why I am telling you, you are not present. No, I know. Just now you came. Don't do like that. Easily we can find out. I am seeing online who are all present, and that's why I am asking. Today I did not teach distortionless transmission line. Switch on that video. So today's class I have explained about types of transmission lines, what are primary and secondary constants, then transmission line equations.
sir, audio.
Okay.
Okay, sir.
So if you are unable to attend the class, I will share the PPT also, but
Yes, sir.
you will be losing your attendance. I will cross check this attendance with Google Meet attendance. In Google Meet, I will get who is present from what time to what time. Just now, last minute is coming for attendance or not, I will know everything. Okay. Don't do like that.
Okay, sir.
Anyhow, I will share the PPT, you follow that.
Okay,
Okay.
sir. 489 present.
489. Yeah, I have taken your number already.
Okay, sir.
I know who are all present online. No, I know from that you are getting participant list. No, from participant list I am getting all those numbers. Okay.
Okay, sir.
So this is about today's class, students. Try to attend regularly. Already these topics are covered during offline classes also, but once again I am revising them so that you people can understand in a better way. So after completion of these classes, maybe you will be having a test also. We will see how we can conduct multiple choice or like that. Only intention is you people has to understand in a better way. Okay. Okay, thank you for your patient listening.